So today we're going to be talking about factoring. We have two lessons on factoring, so today will be the more basic types of problems. We are going to go through all of these special patterns today and tomorrow because we do need to recognize and be able to use these, but we're not going to use all these today. Some of them will be in the next lesson. So the first one we have is the difference of two squares shortcut, where if we have something squared minus another thing squared, that will factor to a minus b, that's something, the square root of both of those things, times a plus b, the square root of both of those two things. Now, something very important to understand is that this is the difference of two squares, not the sum. So if I had a squared plus b squared, this is not factorable. That is a very common mistake that people make, that they think there is a sum of squares. There isn't, it's just a difference of two squares. Right, the next shortcut we have is called the perfect square trinomial, where if I have a squared plus 2ab plus b squared, so if I have something squared plus something else squared, and then the middle term is 2 times the square root of a and b, a squared and b squared, then that will factor into a plus b times a plus b, or a plus b squared. Now the same thing applies for subtraction, where if this was minus, and if this was subtraction, then it would be a minus b squared. So like if it was a squared minus 2ab plus b squared, that would be a minus b squared. All right, then we have the sum and difference of cubes. So the sum of cubes, or if we have something cubed plus another thing cubed, it's a plus b times a squared minus ab plus b squared. And the difference of cubes, if it's a minus b, then we have a minus b times a squared plus ab plus b squared. So the last term is always b squared right here. The first one always matches what we started with, and the middle one is the opposite of what we started with. So those are the shortcuts for sum and difference of cubes. And then if we have 4 terms, we want to look into factor by grouping. And that's where you look at the first 2 terms. Say, what is the GCF of the first 2? We say, okay, this is x squared, and then we're left with x minus 1. And then once the GCF of the second 2 terms, that's a positive 4, and we're left with x minus 1. And if we did this correctly, if it is factorable by grouping, these two would match, and that's going to leave us with x minus 1 times x squared plus 4. And like we mentioned earlier, x squared plus 4 is not factorable, so this is as factored as we can go in that problem. Now, I want you to understand the difference between a plus b cubed versus a cubed plus b cubed. And this is a good demonstration on why you can't just distribute the third power to both of those. So let's say a is 2 and b is 3. So if we had, let's see, if we had 2 plus 3 cubed, that's going to be 5 cubed, or 125. But if we had a cubed plus b cubed, that would be 2 cubed plus 3 cubed, which is 8 plus 27, which is 35. So those are not the same. This is why you can't distribute a third power like that, or any exponent like that when you have this plus sign there, because you're going to get a completely different answer. All right, so let's do some examples. We have 9 here. When we are factoring, we always want to look for a GCF first. That should be our first step. So here we have a to the third minus 6a squared. I noticed I can factor out an a squared from both of those. So we have a squared, and what we're left with is a to the first power minus 6. Now, if you ever want to check if you factored anything correctly, like GCFs or just any trinomial, you can always distribute back in and say, okay, a squared times a is a to the third. A squared minus a squared times 6 is 6a squared, and that's exactly what we got up here. You don't always have to do that, but it's just something you can do real quick to make sure you did something or did this GCF factoring correct. Now, number 2, we have a trinomial, and I notice that our a is 1, so it's just going to be two numbers that multiply to c, the 16 term, but add to negative 17. So because I know they multiply to a positive number but add to a negative, that both of these numbers, or both of these parentheses are going to have a subtraction in them. So two numbers that multiply to positive 16 but add to negative 17, well, it's negative 16 and negative 1. So this would be our factored form. Number 3, let's factor out a 2 because all of those numbers can be divisible by 2. So factor out a GCF of 2. So we have 2x squared. We factor out the 2, so then we have x squared plus x minus 42. And we're now going to factor this. Two numbers that multiply to negative 42 but add to positive 1. That's going to be x is going to be minus 7 and positive 7 and negative 6. And then we have to remember that 2 that we factored out at the beginning. 7 plus negative 6 is positive 1, and 7 times negative 6 is negative 42. All right, now number 4, we have 2x squared minus 5x minus 12. We can't factor out a 2 from everything because this 5 is not factorable by 2. You can't factor that out. So we're going to have to factor this either using guess and check or by grouping. I'm going to use guess and check, and the reason for that is because when we guess and check, the only way to get 2x squared is if one of these was 2x and the other one was x. And now my last two terms, I got to use factors of 12. And those factors of 12, that'd be 1 and 12, 2 and 6, 3 and 4. There's not a lot of them. And because this number is smaller, like it's a bit smaller than 12, I'm not going to guess and check 1 and 12 right away. I'm going to start with like 3 and 4. The last term needs to be negative, and the middle term needs to be negative, so that means one of these signs needs to be positive and one of them needs to be negative, but we need more negative than positive because it adds up to negative 5. So I'm going to make this one negative, this one positive, and then I'm going to guess 3 and 4. 3 and 4. And then we're going to guess and check to see, okay, we get 3x right here. And what do we get when we do that? We get negative 8x. And that does, in fact, 3x minus 8x does give us negative 5x. So this is our factored form. If we didn't get negative 5x, then we would have to go back and move things around and try something different. Now, number 5 is a difference of two squares because I noticed that 81 is a perfect square, x squared is a perfect square, and 4 is a perfect square. So the square root of 4 is 2, and the square root of 81 is 9, and the square root of x is x. So it's going to be 2x minus 9 and 2x plus 9, and that's our factored form. All right, number 6. Number 6, again, we have 3x squared minus 17x minus 6. We can't factor out a GCF, so we need to do guess and check. And I'm going to do that because there's only one way to multiply and get 3x squared, and that means 3x and x. And I noticed that we need the last two numbers to multiply to negative 6, but when I add the middle terms, it needs to be negative 17, so a big number. So what I'm going to do is I'm going to put negative 6 here and positive 1 there, because looking ahead and when I do my check, this right here gives us negative 18x, and that's almost negative 17. This gives us 1x, and when I add 1x to negative 18x, I get negative 17x. So this is my factored form. Looking at that b term when you're doing guessing and checking can kind of help you to determine which numbers to start with. I needed a large number of negative x's, so I knew I'd want to multiply the bigger negative number by 3, so that's why I put the negative 6 there, instead of putting 6 here at the first parenthesis. All right, so number 7, this is something called quadratic form, and the way you can tell it's in quadratic form is you have x to the 4th power, half of 4 is 2, we have x to the 2nd power, and then we have no x. So we're going to factor it the same way we factored up here. The difference up here is that our middle term was x to the 1st power, middle term was x to the 1st power. Our parentheses had x to the 1st power in them. So our parentheses down here, instead of it being x to the 1st plus a number, it's going to be x squared plus, or x squared minus a number. So we need two numbers that multiply to positive 45, but add to negative 14. That's going to be x squared minus 9 and x squared minus 5. Those two numbers add up to negative 14, but multiply to positive 45. Now, we can also look at this and say, oh, we can factor that. That's a difference of 2 squares. And then we have that x squared minus 5 still. So that is our completely factored answer. Number 8 and 9 are factored by grouping because we have 4 terms. So let's factor out a GCF of just x squared, and we're left with x plus 2. Now, in the second pair, because the first one is negative, we're not going to factor out just regular 25. We're going to factor out a negative 25, and that's going to change this to a positive sign, and this is how we get our two parentheses to match. So this becomes x plus 2 times x squared minus 25, and then we can factor x squared minus 25 to x plus 5 and x minus 5, and that's our completely factored form. Now, lastly, the GCF of our first two terms here, that is going to be 5z squared, and that will leave us with 2z plus 3. And then here we can factor out a 2, and that will also leave us with 2z plus 3. So now we can group out or factor out this right here. So it's going to be 2z plus 3 and 5z squared plus 2. And we can't factor either of those any further, so this becomes our final answer. So hopefully this factoring was kind of just a refresher that once we started doing these problems, you're like, oh yeah, I remember this stuff. I can do it now, because we're going to be factoring a lot this year. So thanks for watching the video. Make sure to like it and subscribe.